In Lesson 6.5, you will apply systems of equations to solve problems and choose the best method for solving a system of equations. So far, we've learned the following methods. Graphing is best when you just need an estimate, because by graphing, you don't always find the exact solution, at least not without using graphing technology. Substitution is a good method if one of the variables in either equation has a coefficient of 1 or -1. Elimination using addition is a good method when you have variables with opposite coefficients. Elimination using subtraction is good when you have variables with the same coefficients. And elimination using multiplication is a good method to use when you don't have opposites or the same coefficients of variables, or you also don't have a coefficient of 1 or -1. So in our first example, it says determine the best method to solve the system of equations, then solve the system. I'm going to go ahead and use substitution to solve this one. I'm going to use substitution because this right here has a coefficient of 1, so I can easily solve this equation for y and substitute it in. I know this method is not a favorite of students. I would guess that many of you would choose to multiply this bottom equation by 4 and use elimination using multiplication, but we need to practice with substitution. So let's go ahead and solve this bottom equation for y. I'm going to do so by adding 8x to both sides. So I end up with y equals 19 plus 8x. Now I'm going to substitute this in place of y, so I can then solve for x. So we're going to go ahead and write 4x minus 4 times, now we're going to put all of this stuff that y is equal to right here, 19 plus 8x equals 8. Now we're going to simplify this by using the distributive property. 4x, now we're going to do -4 times 19. -4 times 19 is going to be negative 76. And then -4 times -8x is going to be -32x equals 8. Now we are going to combine like terms on the same side of the equal sign. 4x plus a -32x is a -28x minus 76 equals 8. Now we're going to go ahead and add 76 to both sides to get the x by itself. So we have a -28x equals 84. Now divide both sides by -28. 84 divided by -28, that's going to be -3. Now let's go ahead and plug that back into one of these equations. I'm going to go ahead and plug it in right here, but I'm actually going to use my rearranged equation. Y is equal to 19 plus 8 times -3. I replaced x with -3. So y is equal to 19 plus a -24, or 19 minus 24. 19 minus 24 is -5. I'm going to go ahead and write that as an ordered pair, -3, -5. Once again, you can check your solution by plugging in -3 for x and -5 for y. You may want to pause the video and try these next 3 on your own. In our first example, this one right here would be a good time to use elimination by subtraction because we have coefficients that are the same. So if I subtract the second equation from the first, 5x minus a negative 2x, that is really going to be plus a positive, so that's going to be 7x. And then 7y take away 7y is 0y. And 2 take away 9 is negative 7. Now divide both sides by 7. X is going to equal negative 1. Now to find the other half of the solution, you're going to plug that into one of these problems. I'm going to go ahead and plug it into the first one. 5 times negative 1 plus 7y equals 2. 5 times the negative 1 is negative 5 plus 7y equals 2. Now you're going to add 5 to both sides to get y by itself. So 7y equals 7. When you divide both sides by 7, you end up with y equals 1. So the solution is negative 1, 1. In the next example, we have opposite coefficients. So I'm going to solve this by elimination with addition. X plus 7x is 8x. Negative y plus y is 0y. And 9 plus 7 is 16. Divide both sides by 8, and we get x equals 2. Now I'm going to go ahead and plug that back into one of these equations. 2 minus y equals 9. To get y by itself, we're going to subtract 2 from both sides. And then be careful here, it's not y, but it's negative y equals 7, which means a positive y is going to equal a negative 7, because you multiply or divide both sides by negative 1. So now if we write this as an ordered pair, 2, negative 7 is the solution. Now this last example, we don't have opposite terms or the same terms, so we're going to go ahead and use multiplication. I'm going to multiply the top equation by 2 because then I'll have opposite coefficients. So let's change that to a negative 6x. Actually, I messed up. We're not going to multiply by negative 2. We're going to multiply by positive 2. 2 times 3x is 6x. 2 times a negative 4y is negative 8y. And 2 times a negative 10 is negative 20. And the bottom equation we're going to leave the same. 5x plus 8y equals negative 2. Now we can go and add these two equations together because we have opposite coefficients. 6x plus 5x is 11x. The negative 8y plus 8y is 0y. And then negative 20 plus negative 2 is negative 22. Divide both sides by 11, and we get x equals negative 2. Now I'm going to go ahead and plug that into one of these equations. I'm going to plug that into the second one. 5 times negative 2 plus 8y equals negative 2. 5 times negative 2 is negative 10 plus 8y equals negative 2. Now to get y by itself, we need to get rid of that minus 10 or negative 10 by adding 10. 8y equals 8. Divide by 8. Y equals 1. So the solution is negative 2, 1. Our last example is a word problem. Jared has volunteered 50 hours and plans to volunteer 3 hours in each coming week. Clementine is a new volunteer who plans to volunteer 5 hours each week. Write and solve a system of equations to find out how long it will be before they will have volunteered the same number of hours. So Jared's total hours, or y, let's have y equal the total hours, is going to be 50 plus 3 times x, if x is the number of weeks, where Clementine, since she's a new volunteer, she's going to volunteer 5 hours each week. So her total hours is going to be 5 times the number of weeks, or 5x. Now, if we want to know when they will have volunteered the same number of hours, I would want to use substitution in this example because y is equal to 5x. So let's go ahead and substitute 5x in place of y. So 5x equals 50 plus 3x. Now I'd want to subtract 3x from both sides since I have a variable on both sides. 5x take away 3x is 2x. And on the right side we have 50. Now to figure out what x is, we're going to divide both sides by 2. So x equals 25, or after 25 weeks is when they will have volunteered the exact same amount of time.